well get started. Today's speaker is Bjarne Strostrup. He's worked on a lot of different areas, including distributed programming on very large systems, but of course he is best known as the inventor of C++. If you've been attending the various advanced programming languages talks, you'll know that right now the C++ Standards Committee is working on the next version of the language, and of course Bjarne is heavily involved in that. Today he's going to be talking about one of the major new features that the upcoming version of C++ is going to have, a revision of initialization lists. And before we begin, just a reminder, this talk is going to be on Google Video, so if you have any confidential questions, please save them until after the talk. Thank you.
So the microphone seemed to work. Now, I know you have a fair number of talks on things that could be called computer science, and a lot of talks on sort of finished products. A lot of overviews. And I thought I would do something different. So this is not going to be computer science. It'll be sort of more like computer mechanics. The idea is what happens when you take your favorite programming language and send it to the shop for a 60,000-mile tune-up. You'll get some of the more serious and scientific and difficult and computer science stuff in the concept talk, which I believe is it at 2 o'clock today? Which is also something I've worked on. But this was just meant to be completely different. So if we want to be respectable, we can call it a case study. And I hope to convince you that details matter. I don't actually think this is a major feature that you capitalize. It's a little thing that it would have been nice if it had worked 20 years ago, and for some reasons it didn't, and now it's hard to fix. But I'll also try to convince you that details are hard. I mean, anybody can design a better programming language if it wasn't for the users, if it wasn't for compatibility constraints, if it wasn't for the way these users have been trained to think, and little things like that. So I'm going to talk about these things, and I hope to convince you about that, and I hope not to convince you that this is just a waste of time and it's too fiddly. It is fiddly, but I think it's very much worth your while. We have not forgotten the picture, but big picture or the type system or something, but that's another talk or other talks. I'll say a little word about C++ OX, and then I'll go into more details than you want to know. Basically, we're trying to make C++ OX C++ 09, not C++ OA, OB, other hexadecimal nonsense. And to do that, we actually have to agree on essentially everything by the end of this year, because the national and international bureaucracies take an awful long time to get their acts together. And we would rather that the nations voted yes with some nice margin, like 22-0, like last time. We have a bunch of language features, we have a bunch of library features, and then we have a bunch of things that combine language and libraries. The major thing about language features would be the concepts, which is a type system for types and for combinations of types and integers and other good stuff. Doug Gregor will tell you about our work on that later. And then initializer lists, boring little things like garbage collection. And we have library features, hash tables, regular expressions, nothing major, but to a lot of people who don't have it and haven't understood that there are things you can do in a language that doesn't come with your favorite compiler. It's good to get it into the standard. And combined features, the memory model, the threads libraries, atomic primitives. You see, some of the really hard things is there, it's being done, just not what I'm talking about today. Initialization is messy. in C++. You can do it in lots of ways, and there's lots of ways that you would like to do, but you can't. We would like to have initializer list for containers. You can use an initializer list, open curly 1, 2, 3, 4 for an array. So why can't you do it for a vector? If I have a tree, why can't I initialize it with, let's see, name 1, phone number 1, name 2, phone number 1, things like that. It seems obvious we should be able to do that. But we can only use initializer lists for arrays and structs. Arrays, they tend to be homogeneous. Structs, they're heterogeneous, just to make life more difficult. We'd also like to have a uniform initialization syntax and semantics. That is, I would like to give one answer to the question when people come and says, how do I initialize my object? I don't want to say what kind of objects. Are you meaning a global object or a local object? Oh no, it was a member, sorry, then I have to do something else. I want one answer. I don't have it today. I have an answer to every question you can ask, provided it's specific enough. That's not uniform and general. And you can have things that looks identical but had different meaning. This is bad. So we need to generalize this. We don't really want conversion problems, surprises. Well, there's many ways of getting them. And we don't want surprises with different kind of constructors if we can help it. And so we want a uniform system that can do everything. Oh yeah, and don't break my code. Nobody likes their code broken. It doesn't really matter what I come with, how nice it is. If it breaks your existing code, you're going to get angry with me. And really, people don't like to type. They like to be able to read things that are terse, but they don't, I don't know what they like, but they don't want it verbose most of the time. People say one thing and do something else, so it's hard to summarize, but it's tricky. Let's go back to a little bit more detail. C provided you with be able to say x of a equals curly braces v, where v is some kind of list of arguments, or maybe a single element. And you can also initialize x of a by equals to v. And if x was an integer and v was 7, both of these two will work. And they'll happen to mean the same. C++ added a whole bunch of stuff to support various notions of programming. The new operator needed to be able to initialize. Then we needed to generalize this syntax to that so that we could initialize an object that took several values. And I used the functional notation because the notion was that you have a function that creates a value, whereas C had the idea that you have a value which you bung into a structure. There's not that much difference between the two notions, but enough that we got some syntactic problems, and you have temporaries, function style casts, other kinds of stuff, and a lot of messy things accreted over the years. I mean, there's perfectly good reasons for private copy constructors, but they really are hard to fit into a general framework. Now, parameterized lists, they're fundamentally heterogeneous, but they look homogeneous. There's a heterogeneous, and that's homogeneous. It means something else, but it looks the same. Notice that when we go for initialization and generality, we would like things to look the same and mean the same. That integer is different from that integer, because that is the number of elements, and that happens to be a value, and the value happens to be of the same type as, roughly the same type as the number of elements. Messy stuff. Curly brace lists can be homogeneous or heterogeneous depending on the phase of the moon. So here we have an integer and something that becomes a pointer. Looks homogeneous, happens to be heterogeneous. And here, well, it looks homogeneous, and it is. So if you think you know the answer, you're wrong. That is, there are so many little things that looks natural and intuitive to people that are natural and intuitive just because you've been doing it for a while. And we have to try and find something that is a synthesis of all of this. It's certainly not science, and if it's an art, it's a fairly low art. It's like doing a puzzle. When do you know you've done a puzzle right? When the last bit falls into place, and not before that. Otherwise, somebody might have thrown some pictures from some pieces from a different puzzle into the pot, and this certainly is the kind of puzzle we're dealing with. Some of the syntactic differences you see here reflects real semantics. Most of them don't. They reflect history. I get seriously beaten up quite often for pointing out that certain things are basically historical accidents. Doesn't mean it's stupid. Doesn't mean that people that did them were stupid. But a lot of things happen because they are sitting chatting with Doug McElroy, and it seems a good idea at the time. Or Dennis Ritchie was arguing with Steve Johnson, and it seemed a good idea at the time. May have seemed a good idea 10 years later. And then the two different conversations turned out to clash when somebody invents something third. We don't know everything, and the world changes. And so what is a good idea? Even if something is a good idea for a decade, it may turn out to be a problem. And many of those ideas were reasonably well thought out, given the environment at the time, what was available in the context and what we knew, but it may not generalized. So we have to deal with this. So this is something I want to work. I want a vector of integers, which I can call sequence, and I want a vector of strings, which I can call locations, and I want to initialize my vectors like that. And I want initialization to work for argument parsing too. So if I have a function that takes an integer, a vector of something, I want to be able to give my sequence to that function and put in a sequence just to go ahead. That makes perfect sense. One of the basic rules of C++ is that argument parsing and a few other things are just forms of initialization, and you should be able to do things uniformly, whether we are doing an initializer like that, or an initializer like that, or a return value for that matter. But this is what we would like to do, and if you think a little bit, you can see there's lots of good uses for that. Basically, there is a fairly hard underlying reason why I would like to do this. When I wrote out my aims for C++, one of the most fundamental and one of the few really language technical rules was we should have the same and equally good support for user-defined and built-in types. So why on earth can I do it for my least favorite type, namely arrays, and I can't do it for one of my favorite types, which is vector? And furthermore, the difference here is embarrassing. It also becomes a real embarrassment because there is no way we can uniformly treat initialization of types as it happens with generic programming. Once you start writing a lot of your code in terms of templates to have it work on all types that has the right properties, then you want the same kind of systems. You can't say, well, this template should work for things that is initialized this way, so I use this initializer. But types that are slightly different wants a different initial. You can't do that. You just have to write the template with the initialization, and it should work. So these are fairly fundamental reasons, even if the details are sort of mechanical. Let me give you an example. Here we have 4 different ways of initializing something. T1 is initialized by an ordinary assignment-looking initialization. The next one uses the functional style. Next one uses initializer list. And the last one uses the create an object of the type and then copy it over syntax. And look, I don't want 4 ways of initializing things, 4 ways of doing things. And I have for a lot of things. It's a mess. And you can sort of, as an exercise, define x and v so that either 0, 1, 2, 3, or 4 of these definitions compile. All of the possibilities are possible. This is an exercise I've done. You can also manage to get the values of some of the initializations to change. That's a little bit harder. And sometimes we only have one syntax. So you can't just say, oh, I like this syntax so much better than the curly brace stuff and the equality. Let's really standardize on this. I won't tell my students about the other ways. This is the right way. No, I have not done that. I will not do that. But there are people who have done exactly that. But you can't. Some syntaxes only works in certain contexts. And even if you believed this, you would be hit by anybody who wrote C who will get to there. So let me very quickly go through some of the examples. Say we have a double v and a type def int x. So this is really yucky. I mean, I'm throwing away information. I hate narrowing conversions. But we get them right there. So everything is all right except that it gives the wrong answer. Let's take a container. Let's take v to be b to be an integer, a vector of integers. Now, fortunately, this doesn't work because we know that we can't assign 7 to a vector. This is perfectly obvious unless you use scripting languages, in which case it's not so obvious. Here we have T2, which is done the proper way for a vector. We give the parameters to the constructor in the parameter form, and then we know it really is the size we're giving. We only know that if we know it's a vector. This is my point. I mean, if you're just looking here, you don't really know. And there's no way of taking that list and bunging it into the vector. That would be nice if we could. And here, well, it's okay. It makes a vector and assign it over there. That's fine. It may or may not be optimized. It usually is optimized, so there's nothing redundant there. We could take a C-style struct. We get a bunch of errors. And we get an initialization by 7 and 0, because the old rule from C is that if you forget to initialize an element, it just gets a value 0. It is assumed that all elements can have the value 0. So that works, and if you are a C programmer, that is actually an extremely useful facility in some contexts. And we can't cast to a struct, so that's illegal. Pointers, I mean, fortunately, most of it fails if we have a pointer type and an integer. Finally, the type system does what it's supposed to do. It stops me from assigning a 7 to a pointer. Except the functional cast has the wrong meaning. It somehow got defined to be any old cast as opposed to the most restrictive cast as it should have been. I had a bad day. It's the only explanation there. We can argue about why I had a bad day, but in retrospect, that was a bad day. If anybody comes and tells them they're a great language designer and they never make mistakes, try to sell them a bridge or something. Now, is this a real problem? Yes. It is a major source of confusion. It's a major source of bugs. So the first thing that comes to everybody's mind is, why don't we just ban all the bad things? That is, if I come and you have this mess and I invent something new and says you should use this instead, so instead of having n ways of getting in trouble, we now have n+1 ways of making trouble. It's much, much better if we could say cut, 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 and we'll have a much smaller thing. Don't invent anything new, just ban some of the things you don't like. Unfortunately, that cannot be done because you need every one of those syntaxes for some reason or other, even if there was an old code that had to work. That we can go for the details of that statement, but it's close to true. And unfortunately, we've managed to have that the existing syntax don't have the same semantics in all cases. Here is a really sick piece of code. It has a unrestricted normal constructor that takes a double and an explicit constructor that takes an int. If you design something like that, you deserve to be in trouble, and your boss should try and stop you. Now, this one is preferred when you have when you know the context. If you don't, so if you say sig1 there, that's not a direct initialization. It looks at all the constructors and pick the right one, which of course is this one. This is good. Pick the right one. Now I'm trying to be specific. I want direct initialization. I want be very specific. You know, it picks that one. Somebody, and I think not me, had a bad day. What? Where? On the previous one? Here, this is a context where it's direct initialization. Therefore, it only considers explicit constructors. This is a technique that will stop you from doing conversions. For instance, that was the thing that stopped the assignment of 7 to a vector to work. You combine that rule, which is very useful, with the rule that you can have more constructors without the restriction that they should all be explicit. And you now end up picking the wrong one.
So that one only looks at explicit ones, the fellow look at all of them?
This one looks at explicit, this one looks at all of them. This is sick. See? If I'm wrong, I don't think it's the other way around. If it's the other way around, it would have made some sense. We can check up on that, but it's bad either way. I chose the worst one, but I did do some looking to make sure that I think I'm right. Okay, so here is something. We have initializer list in C and C++, and it's a nice feature when it works. So let's say we could use it as an why don't we generalize this? Let's use it as initializers, but for all types. Let's use it for argument lists. Let's use it for return values. Let's use it for initializers for new. Let's use it for initializers for members and such. That's the fundamental idea. So can we do that? Why do I have 2 slides there? Yes, this just shows both what I would like to do and what I can and cannot do. And so we just want it to work. And how do we get initializer lists into objects? I mean, if you have a plain aggregate in the C style, you know what the elements are, you know what the values are, and you just bung them in. Easy. That's what initializer lists are for. In C++, you have some members, you have some values, and you go through a constructor. So we invent a constructor that takes initializer lists. Simple. We call that a sequence constructor, and I'll give you the syntax in a business. And the basic rule is, if there's a constructor, then you look for a sequence constructor, and if it works, and if you want to use it, otherwise you use an ordinary constructor with the elements in the curly list, in the initializer list. Otherwise we do it the traditional way. That's the basic rule, and it seems to work. Let me give you examples. Now, when you design anything in a language, you'll get a wild debate about what it should look like. Not quite sure. Maybe because fewer people can understand the semantics than the syntax, or at least think they have opinions about it, but it is absolutely certain if you invent a new language feature, you will get a wild debate about whether there should be a keyword, whether that keyword should look one way or another, whether there should be some syntactic mumbo-jumbo, what it should look like, what it should be roughly compatible with. So we went through a huge list of suggestions of what it should look like. It being a constructor for a type container C with element type E that you initialized with an initializer list of elements. Okay, that really took a long time. And the answer is this. We picked on having a type in the standard library that's known to the compiler. It's called an initializer list of some element type S. And so if you want to deal with initializers, then here vector can take an initializer list of its element type. And what would you do with it? Maybe reserve enough size, enough space and then copy them in. Something like that. But anyway, the way you say you are interested in initializer lists is this. And now you can write that. The semantics is obvious. You simply lay down an array with the right values converted into the right type, and then you, what am I doing? I make an initializer list that refers to that, and then I initialize it with it. Initializer list basically is something that looks at a piece of memory, it knows where the beginning is, it knows where the end is. So we take the elements, put them in the right form, the right type, and give it to the constructor. So the implementation model is trivial. You might be able to optimize this in some cases, but not very often. Not as often as you'd like. So basically, the question is, can we initialize this initialization syntax and semantics to cover all cases? And I think the answer is yes. And this is where the trouble starts, because now we get to the details. This is where compatibility gets in the way, even worse than the sense of aesthetics from the previous slides. There is a paper about it, which you can find on the WG21 site. If you can't find that, you shouldn't work for Google. The revision 3 will come pretty soon. And we're dealing with ambiguity, syntax, narrowing, conversion, C99, header. It's 50 pages of dense considerations of trouble. It's like you take your car into the garage and it's been doing 60,000 miles. There's a lot of cleaning to be done, a lot of scrubbing, not much science, but there's lots of details you have to get right. You only have to get one thing wrong and you'll be unhappy. So I'll talk a little bit about this. Syntax. So the first thing is that every form of initialization in the language can take the curly kind of initialization. So that's fine. That solves, by the way, a very old problem. About every half year somebody asked me, I have an array member, how do I initialize it in a member list? And the answer is, well, you can't. Well, here you can. Just give it the initializer list. It falls out. Aesthetics. I don't know if you like this stuff. You can argue it either way. Look just at the aesthetics for now and think about if you like it, why do you like it? I mean, maybe it's ugly and you just like something new. Maybe you don't like it. Is it for a fundamental reason, or is it just that you haven't seen it before? People's reactions vary dramatically from, wow, this neat, is to, oh, my dead body. The reasons for that varies from deep psychological reasons to type theory to parsing strategies for old compilers and things like that. So give it a chance, think about it. if you're really interested, see the next revision that'll be available in a month, or see the current one that's now, but it hasn't solved all the problems. Yes?
Is there a difference between, on the second line, like you said, x2 open parentheses, open brace, 1, 2, close brace, close parentheses?
Sorry, I think there's a typo here for starters.
Well, there's a type on line
There's a
3, too.
typo there. So what do you, let me get the question again.
So the 1, 2, are these parameters to x's constructor on the second line?
There are, so the question is that comments or constructors? Basically, what it is, it simply in all cases says there's an object of type x, and I would like to initialize it with an initializer list 1, 2. How x receives that initializer list depends on how x is defined. The fundamental rule up there says the first thing I do is to see if there's a sequence constructor. If it's a sequence constructor, it's given to the sequence constructor. If there's not a sequence constructor, it says, is there a constructor? If there's a constructor, it gives those two as the arguments to the constructor. If there's no constructor, it sees if it, by old style aggregate initialization, can do the job.
Can the sequence constructor take any parameters other than the...
Can the sequence constructor take any other arguments? No, but you can define a function that takes an argument of type, say int, and a sequence, and an initializer list. Okay, so arrays and structs. So we have already the case that initializer list does double duty. I mean, the main observation you could say is, why don't we just separate initializer list for constructor arguments? Which is roughly what's done now. And you know, we can't, because we are already doing double duty with initializer list. They work for structs, they work for arrays. We can't change that. This will come back to haunt us. Here is an integer with one element initialized to 2, and there's an integer with a vector of integers with elements 1 and 2. This gets a little bit subtle at times, and we just think we have the best use of the syntax. Okay, so we have to allow the curlies both for ordinary constructors and for sequence constructors. The way it's allowed for both structs and arrays, and it also happens to be allowed for scalars already. So you can initialize double with an initializer list with one element now. Been able to do that for decades. On the other hand, you cannot do the same for something that's not a scalar. And you can do things again when you define a pair that doesn't have a constructor. The only real difference between this and that is that this one has a constructor that takes an argument and this one doesn't. So again, there's something you can do for built-in types, in this particular case a struct, that you cannot do with a class where you have carefully specified what you can do. So the idea is that we'll allow this as an alternative syntax. So if you want to initialize the double with a real and imaginary 1 and 2, fine, you can do it exactly like that. And it means the same. Couldn't possibly mean something else. There's no sequence constructor for complex. And this uniformity happens to solve an old problem. Like if you have a complex that takes nothing, well, it takes nothing, that's fine. We can try and be explicit about it taking nothing. Lots of people get caught in this one. This is a function C4 that returns a complex. Non-uniform syntax creates problems, right? Here we have been explicit about 0, and it works. It means the same as that. So if people get into the habit of writing things like that, they will not fall in that trap anywhere near as easily. Disambiguation. This is probably the worst problem we have. How do we choose? I'm not sure how deep I'll go into this, but the rule is that if it looks like an initializer list, it is if there's a sequence constructor. If there's not a sequence constructor, we'll consider the other arguments. So this means that if I have something with no element, 1 element, 2 elements, 3 elements, it looks like a initializer list, and there's a sequence constructor, so it is an initializer list. All of these do the same thing. I tried to say, can we be safer by doing overload resolution? That is, we just throw the sequence constructor into the set of all the constructors, and then we pick the best match. Now this one becomes ambiguous, because either it was the empty initializer or it was the initializer with an empty initializer list, which happens to be the same thing, but it's still ambiguous because it's two different constructors. That one is ambiguous, that one is ambiguous, and it's all right. You have a long list, so it'll not have a problem. For more fun, pick another argument type, and what is ambiguous and what's not ambiguous changes. So better have a simpler rule, and the simple rule is that the initializer list takes takes priority, I mean. And so here, if you have functions that can all be initialized, you can all try this, and you do normal overload resolution. You pick the right one if there's a right one. If there's not a right one, well, say which one you wanted. Just falls out. This is sort of where the puzzle gets hairy. And to really appreciate the puzzle, you have to sit and puzzle with it a bit. I just gave you our solution. There are more ways of thinking your way out of this, and I don't think they work, but you have to look at it. There's a couple of things we didn't try out in revision 2 that'll be in revision 3, but there's enough in revision 2 to give you a headache. Why don't we just take C-style, they're not called initializer list. This one here is a C-style that takes an initializer list, gives it a type. It's sort of like what we were doing. The only problem is that it's weird. What's the proper name? I don't remember. Oh yeah, this is a compound literal. This is not an initializer list, and it is not a cast. The standard says so. It just looks like it. It is, however, still an L value, so you can take its address and start mutating it. Fortunately, the C standard says that if you mutate it in a loop with a normal control structure, it is actually undefined what is the result of here. Whether you initialize this one with a new value every time or you take the one that got modified. If you go and do GCC for the moment, you will find that it's modified and you get a sequence of values. This is not portable because it's undefined. You want to make this defined so that it's guaranteed to print out 1, 2, 3. I mean, so the next time you get through, this integer 1 means 2, and the next time through, this integer 1 means 3. We're back to Fortran, right? 1 for any sufficiently high value of 1 will be larger than 10. I can do this now. It's unspecified. Now, we don't like unspecified things, so let's make it definite. So we'll change this loop by writing it with a goto. And it's now well-defined and will write 1, 2, 3, 4. So we decided we're not going there. And it's better not to allow this than to have it almost compatible. Almost compatible is what the C crowd does to C++, not what the C++ crowd do to C, in my opinion. So we're staying away from that. So we have the rule that initialization here is going to be direct initialization. That is, it'll work even for explicit constructors, the point we had there before. So we can really write strings here and get the std strings initialized. We don't have to write this. That's direct initialization, where we know the target and can use it. This, you go into the overload resolution mechanism and you have to disambiguate. We don't want to do that. We want the direct. The problem is that this stuff doesn't narrow very well. So what we are going to get this way is we are going to have that this will fail. Because if we don't do narrowing conversions, which we would like to do, this will not work. I think this is a really nice idea. I would like this code to break. So, like in a lot of extension situations, repair situations, you can get almost compatible, but you end up breaking something. This is what I would like to break. This is what I would not like to break. And one of the reasons is that this is actually done fairly recently, very obvious. Okay, here, the character array A, B, C, and the integer 0. Now, a lot of compilers today already detect these kinds of narrowings and warn you. So, in case of a literal, what we need to do is to say that it's only an error if the literal really requires narrowing. So that's what's proposed. That is a subsidiary proposal. First we vote the big thing in, and then we go for this, which is a different issue. But we'll see. So why do we actually mess with narrowing? Not really for this thing here, because you can say, well, this is strange. We're not going to go there. There actually is a fundamental reason why we want to mess with it. Look at this. P char, P char, that's fine, except that this is what sort of turns an integer into a pointer. You don't want that to be happening by accident. You will say, well, this is not an accident, and there's no problem. Fine, I'll believe you. Thousands wouldn't. But now write a piece of code. You have this function here that takes a couple of parameters, and it needs a temporary of type t based on a value of type v. This is not uncommon code in template metaprogramming in particular. That's the disguised version of that one. As usual, we cannot change what this means. This is bad, it's going to bite you. But we can go and look for an alternative. And the alternative is to use this syntax. The problem is that if we don't define this as a more stringent about conversions, then the brackets will get the problem back again. If we have this a special case, we have lost uniformity. So for that reason, I'm proposing that this does not narrow, and it's direct initialization. We will get the same value of type t in all the cases. And notice you can actually only do that if you, well, it has to be uniform. Now, having got that far, we went back and looked a bit on the syntax. By the way, who are we? We is primarily me and Gabby Dos-Reis, who sit there in the front, and then it is secondarily a lot of members of the evolution working group at the standards committee, and then various people who sent me emails telling me what I really should be doing. But anyway, do we allow a of x of a without the assignment? I mean, currently you can initialize a variable with an initialized list, but you have to have an equal sign. If you think in terms of grammars, there's no reason not to, except this is non-trivial. There is a fairly common compiler hack that does the following. It looks for the return type, then it scans ahead to see if there's a curly coming. If there's a curly coming before an assignment, it must be a function. and then it does special magic to do the declarator, in this case A. In other words, very ad hoc mechanism for parsing, look ahead for a curly, and then parse differently if you found it. If you think in terms of LRK, this is not the way you do it, but. So this is a problem. I would like to allow this, but we have to look seriously into the problem of existing parsers and whether we break something we shouldn't. This is not the language we're talking about. This is some people's compiler. Should we allow V equals this one? It's obvious what it means. Assign an initializer, just saying, assign an initializer to a variable. That's an assignment. We know what it means, but do we allow it? If we don't allow it, you get the interesting situation where you can initialize something with an initializer list, but you cannot assign to it, so you have to write the assignment in terms of the operator assignment rather than the assignment operator. Yes?
In the first case, can you define a function that way if X is a function type? If X is a function type, can you...
No, we can't. There's a specific rule that says if X is a function type, that's illegal. There's actually already special rules built in to maintain this kind of stuff. Really horrid, yes? Let's see, in this case here?
Yeah. Would I have to explicitly define for the type of thing operator equals taking an initializer list argument? Or would it fall back to simply operator equals of type V?
So the question is, do you have to define operator equals? The answer is, I'm not assuming any magic here. This is what you can write if you have defined it. You cannot write it for, say, a built-in type.
If I had to just define specifically an operator equals argument as an initializer list, if I had to define operator equals argument as would it create a tangible operator?
If there was an operator equals that took a type that was not a V but could be initialized with 1, 2, yes, you would make it temporary, but you see that's also the case for here. That is exactly the initialization semantics. So the point is, do we allow the syntax? And most people say, obviously, yes. If I can initialize V to 1, 2, why can't I assign 1, 2 to it? Okay, yes, that sounds good. Do you also want to do this? V equals V2 plus 1, 2. I mean, think of V as a complex number. Hey, of course I want to assign the 1, 2 to the complex number. And of course I want to add 1, 2 to it. If these are numbers, I can have my coordinate system and I can get my translations and such. Yes, of course I want that. No problem. As a matter of fact, there is no problem. Here comes trouble. If I can do that, why can't I do that? So I want this one too. And the problem is that there is one expression grammar for both the left-hand side and the right-hand side of an assignment. The grammar for the left-hand side of the assignment comes at the same point as statements. It's beginning of a statement, right? So it could be a block. So if we just see this, we do not know whether it's an initializer list that has somehow illegally crept over to the left-hand side of an assignment, or a block. And there's an arbitrary look ahead because I can make these arbitrarily complex, including more curlies and such. Ouch. There's an easy solution. Just factor the grammar completely for expressions. I'm not sure if people are willing to do that, but this is a question. You have to answer these questions. The point is not whether this is what you want. I can assure you some people want it. I can also, but it's a problem of can you fit this into an existing language with an existing technology for parsing it and analyzing it, and you can't escape the questions. And finally, do we want to do this? We want to do, say, initialization with indexing with tuples? Why not? I know people want to do this. There is no technical problem with this. It's just a decision. And you have to go through and find all the places in the grammar that can create problems and see what you can do or not do. By the way, I can see Gabby's head sort of nodding off. He has implemented most of this. This is not science fiction. Not this one, but I believe that one is implemented, yes, and the others are, and that one is implemented. But we do have some problems here. Boom, boom, boom. That was the wrong way. Standard, and then you have to integrate it into the standard library. So otherwise, I mean, this was why we wanted this, right? So you go on and give it vector. So I'm going to stop here and take questions. Yes?
This is a minor question. If I have a matrix, can I take an initializer list of an with a type initializer list? In other words, can the T in that be an initializer list itself?
I had one more slide. There's your answer. You can take a vector, and of course the elements of an initializer list can be initializer lists. And it all goes down. So if you want a 3D vector matrix, you can do that too. No problem. Yeah.
What's the type of initializer list? So far you've only shown homogeneous ones.
What is the type of an initializer list? That's a real tricky question. And you'll have to do for revision 3 to get the exact right answer. Ideally, you want everything to have a bottom-up type. And if you did that, the type of initializer list would be a union type or a product type of all its member types. And this would create havoc throughout the type system. So the rule is that we don't ask what the type of an initializer list is until we have found what it's being initialized to. And then we say, okay, this element knows what this initializer knows what it wants, and we'll see if we can convert all the elements into the right thing. That takes care of arrays, it takes care of sequence initializers, it takes care of constructors, it takes care of everything. Now, the only place where you would have to ask the question, what is the type of initializer list, is if you want to deduce some type. Like you have a template, say you have a vector of t, and you have it initialized with an initializer list. Then you want to deduce t. And there are certain forms of overload resolution too where you have to make some deduction. If you have to do any form of deduction, say, we have two choices. We can say we don't know what the type is. Forgot about the product types. That doesn't work. What we actually say is that if any deduction is needed, the list has to be completely homogeneous. No conversions of any form. In which case, it becomes the initializer list of its element type. I really don't want to be in the situation of having to decide whether the initializer list 1, 1, 1, 1, 1, 1, 1.0, 1, 1 is an initializer list of doubles because you can promote all the integers to doubles, or initialize a list of integers because there's only one little double out there. If I get time, I developed a little type system based on metrics for this. And if I get time before April the 1st, I'll write it up. But no, the rule is what it is here. It has a type that you can use in deduction situations if and only if it's completely homogeneous.
Well, the question I had was, so far you told us how we can declare a constructor which takes a homogeneous initializer list. You said you give the constructor with an initializer list parameter. But the second example is a non-homogeneous one. How would I declare a constructor which takes an initializer list with two elements?
I mean, for instance, the map here, I will have a sequence initializer that takes pairs. That's still homogeneous, and pairs will take a non, they'll take an ordinary constructor that takes a string and an integer. That's not homogeneous. So it just falls out. Yeah, a sequence constructor will take homogeneous ones, provided they can all be converted to the same type. Ordinary constructors will take non-homogeneous. I have several questions in the back, so I'll switch to those.
So for historical reasons, you need to allow curlies to mean either homogeneous or heterogeneous initializer lists.
Yeah.
But it seems to me that you don't ever really want one to be substitutable for the other. If it wasn't for the historical reasons, I would really like to make that distinction explicit. There's nowhere that I want to write an initializer list that I want to be interpreted either homogeneously or heterogeneously.
I don't believe you. Okay, I mean, I could be very polite, and I decided to be the exact opposite. I have never met anybody that when they actually started writing code could maintain that purity. It's people do mix things up, and people do want conversions. So my guess is that even if I decided to do this today, you could say initializer list is just initializer list, and the other syntax is for the rest. I would definitely try this again, but this is a slightly different problem. So, and it has different problems associated with it. In particular, you immediately say, well, it's non-homogeneous, but then you say, well, it's non-uniform. But you can say, oh, it's uniform because it's uniform in the way we initialize. It's just as these particular initializers that are initializer lists. The problem is the minute people then start to want both homogeneous and heterogeneous initializer lists, we get problems with where we can deduce things, which was the tangent I went out on him. And we get a whole new set of problems. So maybe there are two solutions, one where they're uniform in terms of the syntax, and one where the syntax is uniform, but there's heterogeneity in the way we use the list, but the problem will come up the one way or the other.
If I could just clarify,
Yeah.
I think what I was talking about was the one thing that makes me feel slightly uncomfortable is the sort of fallback of either matching an initialization list constructor or matching a normal
Yes.
constructor. And it feels like, let's say if ASCII had some sort of extra brace types in it, and you had like, you had like curly 1, curly 2, if you had the option that I could say have a curly with a subscript on it that says this curly really means an initializer, like a initializer list, a homogeneous versus heterogeneous.
We've been there. I'll get back to you right away here. So first of all, the lists turns out to be homogeneous, heterogeneous, whatever, and people want them in. And if you really, really want to say this is a list, you actually have two ways of doing it. You can simply say initializer list of T, and then it is a particular initializer list of T. And then somebody observed, I think it was me, that this problem only appears for very short lists. For big lists, they'll never match anything but the initializer list. So the problem happens almost invariably with lists with 1 or 2 elements. 0 takes care of itself also. So you really want to be able to distinguish saying this is an initializer list of 2 elements. You can write initializer list, but that's so long. Well, there actually is an escape clause that's been in the language for 30 years or so. You write open curly, 1, 2, close curly. I would much rather have had a prefix and suffix, but since the problem only appears for 1 or 2 elements, put that comma at the end, and it'll never be interpreted as anything but an initializer list. As I said, this is a low art. It's a very complicated puzzle with many, many dimensions. But I do think that if it had been unconstrained, it would still have been a hard puzzle, because people's needs of initializers are amazingly varied. Anytime people think of a great idea, They'll put it down into their code as some kind of object or class or something, and then it'll start initializing it. Therefore, you get just about anything people can think of as an initializer list. That's where the fundamental problem comes, yes?
So will initializer lists be a full-fledged type in the sense that I can stack allocate an initializer list of int and manipulate it in some way? Things like that are really malicious.
An initializer list will be an R value. Oh, I have to repeat the question. Are they a first-class thing that you can manipulate? In some sense, no, they're not. The idea for an initializer list of, say, the element 1 is the integer 1. They are values, not objects. And so you can create, and so you cannot have a variable of type initializer list and do all kinds of things with it. The model is 1, not the integer a. This is the problem I had with the C example. I really don't want 1 to have any more values than 1. So this kind of first-class ideal is definitely compromised right there. But I think in order for another, an even more fundamental ideal, which is that values are values.